Hello, is my audio audible?
Hello, is my audio audible?
Okay. Okay. Ah, it's been a long time. நம்ம யூடியூப்ல கனெக்ட் பண்ணி actually I started this video எங்கள் அம்மாவோட பர்த்டே இன்னைக்கு. ஸோ ஐ வாண்ட் டு விஷ் ஹர் வித் திஸ் வீடியோ. ஸோ ஹாப்பி பர்த்டே அம்மா. அண்ட் மோர் ஓவர் இது ஒரு விஷ் பண்ணுற வீடியோ மட்டும் இல்லாமல் ஏதோ ஒரு வேல்யூ ப்ரொவைட் பண்ணலாம் அப்படின்னு தான் நான் இன்னைக்கு வந்திருக்கேன். ஸோ இன்னைக்கு நம்ம எதை பற்றி பார்க்க போகிறோம்னா ரியல் வேர்ல்டு அசெட். ஓகே, ஆர்டபிள்யூஎஸ் பற்றி பார்க்க போகிறோம். ஆர்டபிள்யூஏ. ஸோ ஆர்டபிள்யூனா என்னது? ரியல் வேர்ல்டு அசெட். ஃபார் எக்ஸாம்பிள் ரியல் லைஃப்பில் இருக்க ப்ராப்பர்ட்டிஸ் எதை வேணாலும் இருக்கலாம். ஓகே, மிக்ஸ்டு ஸ்பேஸில் இருக்க ப்ராப்பர்ட்டிஸை வி ஆர் ட்ரைங் டு டோக்கனைஸ். ஸோ வி ஆர் மேக்கிங் அஸ் அ டோக்கன் ஆன் எ பிளாக் செயின். ஸோ இன்றைக்கி பர்டிகுலராக வி வில் லுக் இன் டு டெஸ்லா. ஸோ எல்லாத்துக்கும் டெஸ்லா தெரியுங்களா? டெஸ்லா ஆட்டோ பைலட் கார்ஸ் எல்லாத்துக்கும் தெரியும். ஸோ இன்றைக்கி க்ரியேட் பண்ணுற டெஸ்லா வந்து சிந்தட்டிக் டோக்கன் விச் இஸ் மோர் டீசென்ட்ரலைஸ்ட், but it is not directly pegged to the Tesla stock which is in the brokerage. Instead of that, we are going to provide collateral that equals the value of the Tesla stock on a brokerage. So that's very crazy, right? Okay, fine. So yes, Tesla token, synthetic Tesla token. Okay, I have already cloned the code. Code already நான் clone பண்ணி வச்சிட்டேன். Before moving on to the code, let me explain the few important logic. Okay, fine. So what you have to do is, as a user, there are two main functions. One is the deposit and mint, and then redeem and burn. These are the two important functions that we are going to look at today. This is one function, and this is one function. These are the two important functions that we are going to look at today. So as a user, what user does it? User comes into the protocol, they deposit Ether. So Ether is the native cryptocurrency for Ethereum blockchain, right? So they deposit the Ether and they request for the Tesla mint. Fine. So that's what this function means. That's what this function really means. So we deposit the collateral and request the mint for the Tesla tokens. Fine. Okay. So inside the mint function, there is an important internal function. So what is the internal function? Health factor. This is very important. I will explain you why, right? Okay. So what is the flow? What is the next flow? So once the user has deposited the Ethereum as a collateral and he have requested for certain number of Tesla token, so the next step what you have to do is, as a protocol, we need to calculate the health factor, right? How do we calculate the health factor? First, we let me change the color. Okay, so we need to call the health factor. What happens in the health factor? All right, let me go for the black. Okay, what happens inside the health factor? So we get the amount of Tesla and the amount of Ether. So once after we get the amount of Tesla and amount of Ether from the mapping, all right, from the mapping. So I will explain you how to get it. So we have two mappings. You can see the Tesla minted per user, Ethereum collateral per user. Okay, after getting the amount, we need to calculate the USD value of Let me expand this. Hope my screen is visible, right? Okay. Let me check. Fine. Okay. So we calculate the USD value of Ether that we have deposited as a user and the USD value of Tesla. Okay. So why எதுக்கு bro? எதுக்கு why do we need the USD value of Ether and value of Tesla in USD to calculate the health factor? So the basic நம்ம என்ன பண்றோம்னா the collateral should be more than the value of the synthetic token. For example, let me give you an example. For example, um, if we have if I have deposited $200, if I have deposited $200 worth of USD value of Ether in the protocol, I can mint $100 worth of USD value of what? Tesla. So that's how the protocol works. So we need to take care of this. Why? Yeah, now sometimes the collateral value can crash. What if the Ethereum values drops very soon, right? For example, இன்னைக்கு வந்து ஈத்தீரியமோட price என்ன? ETH USD price இன்னைக்கு வந்து $2,900 இருக்கு. What if it drops to $2,000? So what I'm trying to say is the Tesla is no longer pegged to the Tesla value because the collateral value is less than the synthetic token that we have minted, right? Okay, fine, bro. We got the value of Ether and we got the value of Tesla. What's next? What's next? Uh, as Ether is the collateral, right? Ether is the collateral. You have to multiply the Ether by collateral ratio divided by collateral precision. So here you can see calculate the health factor. We're getting the USD value of Tesla, USD value of Ether, and we are passing this through the internal function calculate health factor. Let's go into this function. Over here, you can see the collateral value in USD is multiplied by the threshold, liquidation threshold divided by liquidation precision. So as you know, solid retailer we don't have floating point number. So whenever you multiply a number, you need to divide by the precision, right? That's what we are doing over here. Okay, what is the liquidation ratio? 50. This means you need to be 200% over collateralized. That's what I was trying to say. Fine. And then the liquidation precision is 100. If you multiply by 50, you need to divide by 100, making it as a 1 divided by 2 half, right? Okay, brother, we have multiplied the liquidation ratio, liquidation precision, that's fine. And again, we have to divide it by, we have to divide, after multiplying, we have to divide the value or the result, that is 200% over collateralized collateral, by the USD value of Tesla. So this returns a value, right? This returns the value, get health factor. We are using it inside the deposit. Let me give some space over here. Inside the deposit and mint. So yeah, deposit and mint. Fine. Yeah, deposit and inside the deposit and mint function, we're using the health factor. So we are checking if this health factor is less than the minimum health factor. What is the minimum health factor? It's going to be 1. Right, 180. So if it is less than 1, then we're going to revert it. If it is greater than 1, we're going to mint. This underscore mint comes from the internal function ERC20 commander underscore mint. So this is an internal function we are using, making use of OpenZeppelin. Right, fine. Okay, what's next? We got the health factor, and we are clear with how the deposit mint function works, right? So we are done with this part. Next, what about the redeem and burn? Now we will look into how the redeem and the burn works, right? As a user, after minting the Tesla token by depositing the Ether, all right, by depositing the Ether, I have to redeem the Ether. So what is being by redeem and burn? I'm going to burn my Tesla token for the equivalent value of Ether. and I'm going to get back my own collateral, right? Okay, fine. Let's see how it works. So the user request for the burn, and this user sends the amount to burn, right? Amount to redeem. This is the amount that the user wish to burn for their collateral. Okay, so now now we have the number of Tesla Tesla token. Now we have to find the USD value of Tesla. From the USD value, you have to get the ETH value, right? So it's like this. Let me show you. Let me show you a mapping. So as a user, I'm providing you the number of Tesla that I'm wishing to burn. From the Tesla, we get the USD value. From the USD, we get the ETH. So the ETH amount that equals the value of USD, that equals the value of Tesla. That's for this two line. These two lines are very important. So get the USD amount from the Tesla, get the ETH amount from the USD. After getting the amount, reduce the mapping, recalculate the health factor, check if the health factor is still greater than 1. If it is greater than 1, then burn the Tesla tokens and send them the equivalent value of Ether. So that's how it works. We'll go through like how do we get the USD value or the USD amount from the Tesla, right? These are the view and the view functions. We will get to it. Okay, let's first check how do we get the USD amount from the Tesla. Fine. So we pass the number of Tesla in wave. We have to multiply by the value of one uh, Tesla token in USD. So amount multiplied by value of one Tesla token in USD, which returns the value of amount of Tesla tokens in USD, right? So we get the USD value. How do you get the Ether from the USD? So uh, to get the amount of Ether, so to get the amount of ETH from USD, we have to what we have to do. We have to divide the USD by value of one ether in USD, right? So if I go back to this function, get ETH amount from USD, if I go inside this, so here we are getting the value of one ether in USD. All right. So USD divided by value of one ether in USD. That's what I said. USD divided by value of one ether in USD. You get back the amount of ether that equals the value of USD amount that equals the value of Tesla that the user is requesting for burn. Uh, that's how this work. Maybe if possible, we can go through the health factor, how to calculate the health factor, right? Because they get health factor. Here we get the USD value of the Tesla that the user has minted and the USD value of Ether that the user has deposited. And we pass both of this parameter into this calculate health factor where we multiply by the threshold and then divided by the Tesla value in USD, which returns as the health factor, which we use in both this deposit and mint function and redeem and bond. Right, fine. Now we have done with the contract. Now we can move on to the testing part. So as you all know, it's very important to test a contract before deploying to the mainnet because the contracts are immutable. Once deployed, it can't be changed. And also, as the code is publicly available, you have to make sure like every line of code is tested well and fine before deploying, right? Fine, let's move on to the test. As this involves aggregated with the interface from chain link price feeds, you have to, as I'm testing in the Anvil chain, so Anvil is a local chain, local development chain that comes with the Foundry framework. So in order, this is a local chain, right? It does not has the chain link contracts which are already been deployed in the mainnet. So we have to deploy the mock contracts before testing our contracts. That's what we're going to do now. Let me explain you the test. So inside the setup function, we are getting the Tesla price speed, ether price speed. This was I told. Inside this function, uh, so where does this function comes from? Deploy st eth. So give me a second, brother. I will come. All right, guys. Now we will look into the testing part. Hopefully, you are getting this. If you have any doubt, உங்களுக்கு ஏதாவது டவுட் இருந்தா தயவு செய்து கமெண்ட் செக்ஷனில் போடுங்க. நான் ரீச் பண்ணுறேன். ஏதாவது டவுட் இருந்தால் கேளுங்க. Okay, fine. Test. What we are doing inside the test. So from this deploy S Tesla, we're getting both the mock Tesla of price speed as well as ether price speed, um, which we are going to pass it into the deploy. Uh, okay, so this is an important function. Okay, get Tesla requirements. This function returns the price feeds, and this function deploys the contract and returns the contract to this variable. Right, fine, got it. And this is the first function, test can mint Tesla. So what we are going to do, we are going to fund the user with the starting ether balance of 100, and the user, we're going to prank the user, we're going to deposit 100 ether, just the 10 ether, and further we're going to mint 1. So at the end of the day, as a user, the user is going to have 1 ether. So let's test this function and check if our contract is right or wrong. Forge test session b. So this is how you do the test. Name of the test dash v. This is for visibility, and dash y dash ir. So this is to convert the contract into intermediate representation, which is U. Now if I run this, it should pass. It is, the contracts are being compiled right now. Okay, as you can see, the test has passed successfully. So what is the conclusion? If the user has 100 ether, and if the user deposit 10 ether and request for 1 Tesla token, the balance of the user is going to be 1, right? Or we can also assert, I think we can also assert uh, mm, oh, I think after it's going to be 90. I'm not sure. Let's try this. Wire dash AR. It passes. So which means like after depositing 10, initially he has 100, right? So after depositing 10 ether, now he's going to have 90 ether. So that's how that works. Okay, next we will go into the burning, the redeeming phase. All right. All right, let me close the terminal. Here you can see we are dealing the user. The user deposits and mints 1 Tesla token. And to burn the Tesla token on behalf of the user, we have to approve. The user has to approve the Tesla protocol. So that's what is going on. The user approves one Tesla to our protocol address. Once after that's done, we are checking the balance of the Tesla before burning and the balance of the Tesla after burning. Before burning it was 1, after burning it's 0. Alright, so let me test this contract to clear forge test dash dash empty. Paste the contract name dash bbbb for visibility slash slash via dash ira. Intermediate representation for optimization. Got it. Okay. Once this is run, maybe we can discuss about how to deploy the mock. Here you can see we are calling two functions. Uh, Among these two functions, this is very important function. So we are getting the requirements, which is inside this contract, this function. Fine. This gets two things: the Tesla feed and then Ether feed. So where do we get from the helper config, active network config? So we'll go to the helper config, active network config. Where is the helper config? Active network config. So here we are assigning the active network configs as we are testing in the annual chain. So we go inside this 31337. So here we are defining the mock for the Tesla price feed and Ethereum price feed. These are both are the written values that we needed. And once all of this has been set, I think this is our state variables. No, no. Where are we defining this? This is an internal function. I think this is a memory variable. I'm not sure. Is it defined somewhere else? Yeah, that's a state variable. That's how you define the state variable. Fine. So you deploy the mocks, and then we call the get anvil, which returns the active network config. From this network config, we are just interested in getting the Tesla price feed and the Ether price feed. So both of this we're getting over here. Tesla feed, Ether feed. That's how we get it. And let's see the initial answers for the Tesla. So initially it is $2,000, and for the Ether, the same $2,000. Fine. I think that's it for today's session. Hope this is clear. We went through. Okay, let's do the summary. Like the live streamல என்ன பண்ணோம்? Okay, the live streamல we just first எங்கள் அம்மாவுக்கு நான் விஷ் பண்ணேன். செகண்ட் வந்து we went through the entire protocol, how it works, mainly the two functions, deposit and mint, and then the redeem and the burn. We also eh, like go we also explained about how the health factor works and how to calculate the user's health factor, and how the conversion between the Tesla to USD and from USD, how to get the Ether. USD divided by value of one Ether, which returns the Ether amount. And finally, we went through the test script, and then we also went through how to deploy the Tesla mock price feeds for mock, right? So here you can see we are making use of this deploy inside the setup function. It calls two functions, requirement and then the deploy. This deploys the contract and returns the contract. This gets back the Tesla price feed and Ether price feed from the helper config. Inside the helper config, we are deploying it. So hopefully this is clear. Okay, I'm going to end the stream now. I don't know how long it took. Okay, it's been half an hour, 26 minutes. Okay, anyways, take care, have fun, எல்லாரும் ஜாலியாக இருங்க. ஏதாவது டவுட்னா எனக்கு கேளுங்க. பாய்.